Yeah, that's for me.
So, when this is gelled, essentially it will not turn into a solid block, but it will demonstrate a distinctly different, it's very much like Jello, it will demonstrate a distinctly different stage. So there are sort of three phases. The liquid, and as it gels, it's still very taffy-like, but it'll actually, if you don't pull it, its elastic yield is very small, so if you pull it, it will start stretching plastically. But if you peel the layer off, it just wants to stay exactly where it is. And so you have this nice place where you can peel the layer. It's usually about an hour. It's usually about an hour in, but it will depend on temperature, which is why I always have the cup with me. And so I'll mix the cup again until I notice it's at the gel state. Unfortunately, it's sort of a gut feeling, kind of, this looks right.
And you can't reuse this thing.
Well, you can chunk the silicone up. If you want to recycle silicone, you can chunk it up. I have friends who work in mold making who use a meat grinder, and you can mix it in with other silicones. It's not ideal for this because it could introduce air bubbles. But if you were making these molds, like some of these molds for other shapes, I've actually mixed in ground silicone because it stretches it out. Silicone adheres to silicone well enough that it doesn't make a difference.
If you automated the pressure, how fast could that move?
This guy, well, I'm going to show you a video. I gave some of these away to other groups to experiment on, and hopefully it doesn't get too loud. I can't really control the volume too well. Go. And go. Anyway, okay. So this is the fastest I've seen someone get this. Yeah, so this was, I gave one of these Smooth-On, came to do a little documentary on, like, here's somebody using Smooth-On in a weird way, and I gave them a blockage to play with themselves. So that's the fastest I've seen it go, and they're actually using a switch valve. And so they've got a pressure supply, and they've dialed it down to a low pressure, and they're just flipping a lever back and forth.
Are you following the Festo Bionic learning network?
No, I hadn't known.
We've been working, Festo is from Germany.
Yeah, I've seen some of the promotional videos.
Yeah, so they have an elephant trunk that is hanging upside down. I was working on that 5 years ago.
Cool.
That was really fun, and it was nice to hear, just where we used to upside down, and we had grippers, and could move it.
Yeah, I've seen the compliant grippers, the ones that are sort of walk-wise.
Yeah, so that's nice. Yeah.
They're
Finray.
They're the three ones that are.
Finray grippers.
Yes.
Yes.
Are the elephant trunks pneumatic?
Yes.
Cool.
They also have, it's also the same setup, so you have a three, how do you call them, tubes that would extend when the pressure rises, like three in a triangle, and then depending on which one you move, you can either bend it or just extend it. So you put pressure on all three of them, it just go longer. If you put pressure in one, it just would bend, and so on. And then they had three of those, the three pieces together would be one piece, and then three of those stacked on top of each other, and it would narrow down. And then at the end, they would even have like several ones that would move just the gripper. So there was a lot of range of motion, but it was a fun project. I think they worked on it afterwards. So.
Yeah, it's mechanically similar. I worked on snakes on a plane. It's like my first
Snakes on the plane were built like that as well?
Yes. So the way they worked is we had a spine and there were wire control. So instead of air extending them, there's wires compressing them, and so there was a spine, and then there were concentric holes in each of the spinal discs, and so for each segment of motion, one set of wires would be tied to the spine, and so they would control that segment, and then more wires would pass through, and so segment 2 was another joystick, so it could get sort of one curve and then the other curve up until you got the final wire controller, remote control servo for the head, whatever the head is. Some of them, you know, being a movie magic, but some of them just like put out fangs and made a face, and other ones actually were supposed to do something. It was actually originally it was called Pacific Air Flight 121 until Samuel Jackson demanded it be called Snakes on Fire. So,
this just gives away the whole movie. I mean, you know, you already know what it's going to be about.
You mentioned that you kind of like skirted around simulation and modeling a bit. So if you had more of that going on, if you knew somebody, or if you experimented a little bit more with that, what would things look like? How would it change your approach, and what would you be doing in addition to what you've been doing?
well, one thing that's more difficult to do in CAD, but is probably amenable to modeling, is trying lots of different actuator geometry. So I use a rib actuator. The idea being, the expansion happens perpendicular to the ribs, and so I get bending. But there are probably a lot of ways to do that. So the way the Whiteside's lab at Harvard does it is they actually create more surface to bend by sort of, it's not quite a space filling curve, but they zigzag the internals of their robot, and so when that chamber expands, it has a lot of surface area to unfold accordion style, and so that creates, it's a different shape actuator, but creates the same motion. One thing I'd like to do is, test a bunch of different kinds of actuators against each other without having to figure out how to fabricate them, because I have fabrication methods